Today we're going to talk about how to solve systems of linear equations with three variables. You have solved systems in the past using elimination, substitution, and graphing. All of the ones in the past we have done with been two variables, an x and a y. So today we're going to add on a third. Just to review elimination from the past, if you recall, if you look at this example right here, if you will notice if you add down right away, you will notice that your x's cancel as they're written. You end up with 5y equals 5. 3 plus 2 is 5. 1 plus 4 is 5. If you then divide by 5, you get y equal to 1. Once you get y equal to 1, you can then plug that in and plug in the y right here for that variable. And you'll get x equal to -2, and then you got your solution -2, 1. So that's what we're going to do today, but we're going to do it with three variables instead of two. So here's the methods for solving a three-variable system. We're going to learn a bunch of different ways to solve them, but the first way we're going to learn is called elimination. All right, so here's how you do elimination. You pick two of the lines. So I'm going to pick my top two, and you decide what variable you want to get rid of. I'm going to choose to get rid of the x variable. So because my two x variables do not cancel as they're written, I know if I multiply my top line by -2, now when I distribute that through, my x's will cancel. So off to the side here, I'm going to distribute that -2 through to all four pieces. So that becomes a -2x minus 4y plus 6z equals -22. Once I do that, I'm then just going to take my second line and write it underneath it just to stay organized. Once I get to that point, I'm then going to add down. So when I add down, my x's cancel. I have a -3y plus 4z equals a -13. And that's my first step. After I do my first step, I pick two other lines and I again get rid of the same variable. So now I'm going to pick my middle and my bottom, and I have to again get rid of my x variable, same one I got rid of in my first set. These do not cancel as they're written, but if I multiply my top by -2, I will then get my x's to cancel here. So if I distribute that -2, I get a -4x minus 2y plus 4z equals -18. Once I have that written down, I then just take my other line and I write it underneath just to stay organized. And I add down again, just like I did before. So my x's will again cancel. -2 plus 3 is 1y. 4 plus 1 is 5z, and -18 plus 16 is a -2. Then I take this one and I put those two together. And I decide what variable I want to get rid of now. Because this is -3 and 1, my y's seem to be easiest to get rid of. So I'm going to multiply my bottom line by 3, and if I multiply it by 3, then I know my y's will cancel. So I have 3y plus 15z equals a -6. So when I distributed that through, that's my line. I'm going to just rewrite that other line underneath to stay organized. And now when I add down, my y's will cancel. I have 19z equals -19. If I then divide by 19, I get z equal to -1, and that is the first part of my solution. Once I get z, I have to plug that back into either this one or this one to get y. So I'm going to plug it in here. So I have 1y plus 5 times -1 is a -5 equals -2. I'm going to add 5, and I see that y equals 3. Once I have two of my values, I then go back to one of my three original ones. I'm just going to take my bottom one, and I'm going to plug in these two values to get x. So I have 4x plus y is 3. 3 times 3 is 9, plus z, which is negative 1, and that equals 16. 4x plus 8 equals 16. If I subtract the 8, I have 4x equals 8, x equals 2. So my solution to this problem is going to be 2, 3, negative 1. That is my x, y, and z. And that is how you solve with elimination. We'll try one more problem. So again, I'm going to go a little bit quicker. I'm going to take my top 2, and I'm going to multiply the top by negative 2 this time to get my x's to cancel. So I have a negative 2x minus 2y plus 2z equals 18, and that is my first step. After I do that, I'm just going to write my second line right underneath it just to stay organized. So I have 2x minus 3y plus 2z equals 13. When I add down, my x's cancel. I have a negative 5y plus 4z equals 31. I'm then going to take my bottom 2, and I'm going to get rid of my x's again. This time, though, you will notice instead of just multiplying one by a number, I'm actually going to multiply them both by a number. So if I multiply this by 3, that gives me 6x. If I multiply this by 2, that gives me 6x. I just need to make one of them a negative. So when I distribute the 3, I'm going to maybe do it right underneath here so it's close. I get 6x minus 9y plus 6z equals 39. And then I have a negative 6x plus 10y plus 12z equals 30. So then when I add down, I have 1y plus 18z equals 69. I'm then going to move him over to my other one. And I now have to choose another variable to get rid of. So I'm going to get rid of my y's, and I'm going to multiply my bottom by 5. So I have 5y okay, 5 times 18 is 90z, and 5 times 69 is 345. I'm then going to just rewrite this one underneath it, and I'm going to add down. And when I add down, it looks like I get 94z equals 376. So I take 376 and divide by 94, and I have z equal to 4. Once I have z, I'm just going to plug it into this one right here because it's right there and easy. Y plus 18 times 4 is 72 equals 69. Subtract the 72, y equals negative 3. And then I plug it into my top one. It says x plus y minus z equals negative 9. So I'm going to plug in negative 3 for y. I'm going to plug in 4 for z. Those combine to be a negative 7. I'm then going to add 7, and x is negative 2. So my solution here is negative 2, negative 3, 4. So that is how you solve with elimination. The next way of solving is with substitution. So what you have to do with substitution is you have to plug in some variables and try and get some things so they can substitute out. So the first thing I would do is I would take a look here, and I would notice that I have x by itself right here. So I'm going to take this and plug it in for x right there. So I have y equals 5. The x pops out. Negative 4z minus 19 pops in. Plus z minus 4. I'm going to simplify that to negative 20z. 5 times negative 19 is a negative 95 plus z minus 4. So I'm going to one more time simplify that and combine my z's. Negative 20 plus 1 is a negative 19z. Negative 95 minus 4 is a negative 99. So once I have that, I am then going to have y alone. Once I have y alone, I can replace this y with that right in that equation. So I'm going to substitute this in for y. So I have negative 5, negative 19z minus 99, minus z equals 25. So I'm going to distribute. Negative 5 times 19. Negative 19 is a 95z. Negative 5 times negative 99 is a positive 495 minus z equals 25. I'm going to combine my z's together and get 94z plus 495 equals 25, and then I'm just going to keep solving. So in this case, I'm going to take 25 and subtract my 495. I'm going to divide that by 94, and my z is going to equal negative 5. Once I get z equal to negative 5, I'm going to go and plug it back in here. So I'm just going to go negative 19. I'll try and show you over on this side. Times negative 5 minus 99, and z is negative 4. I'm sorry, y is negative 4. And then I'm going to go back to my beginning, and I'm going to use my z to plug in here to get x. Again, z we got to be negative 5 down here. So I'm going to go negative 4 times negative 5 minus 19, and x is 1. So my final answer is going to be 1, negative 4, negative 5. And that is how you solve a substitution. On the next page, we're going to solve using matrices. So here's how you solve using matrices. The first thing you need to do is you need to write your information in a matrix. Your information always has to be written kind of what we call standard form. X, Y, Z equals number, X, Y, Z equals number, X, Y, Z equals number. These have to be all the same variable, these have to be all the same variable, and these have to be all the same variable. And then your constant has to be on this side. What you do is you take the number in front of each thing and you put it in here. So the number in front of the X is a 1, that is a 2, that is a negative 3, that is a 2, that is a 1, and that is a negative 2. That number is a 4, a 3, and a 1. And this is your first matrix. And the way you solve with matrices is we're going to take the inverse of that matrix and then multiply it by another matrix. And this other matrix here is your constant matrix. So you put down the 11, the 9, and the 16. All right, now the way you do this on your calculator is with your matrix button. Your matrix button is located right here. Mine is in blue, so in order to get to that screen, I'm going to go second matrix, and all this information comes in. We put the numbers in under edit. So if I go over to edit and hit enter, you have to tell the dimensions of this matrix. There are 3 rows and 3 columns. So this is a 3, enter, 3, enter matrix, 3 by 3 matrix. And then I just put in those numbers, 1, 2, negative 3, and I'm hitting enter in between each one. And I have my first matrix in. Then I do it again. So I go second matrix, over to edit again, but this time I want to put my other matrix in B. So I go down to B and I hit enter. And this time we have 3 rows and 1 column. So this is a 3 by 1. So then I enter 11, 9, enter, 16, enter. Once I'm done with that, I go second, quit, and get a clear screen. Once I have a clear screen, I now am going to calculate the answer. So I go second matrix. This time though I stay under names, and under A I hit enter, and then I have to take the inverse of that, and the inverse of that is this button right here, this X to the negative 1. So I hit that button. Then I go second matrix again, down to B this time. I hit enter. And you will notice that I have A inverse B on my calculator. And once I hit enter, I got all of my values. and that is your solution. Once you get matrices entered into your calculator, it is much quicker than using elimination. All right, let's try another example. Let's take a look at this one. It says you found $6.60 on the ground at schools, all nickels, dimes, and quarters. So we're going to start with that. My total amount of money is $6.60. Nickels are worth 5 cents, so I'm going to go 0.05N. Dimes are worth 10, so I'm going to go 0.1D. And quarters are worth 25, so I'm going to go 0.25Q. Next, you have twice as many quarters as dimes. So my quarters is equal to twice the number of dimes. And then I have 42 coins in all. So the number of nickels, dimes, and quarters all together equal 42. So those are my three equations. My first equation is in great form, so I'm just going to leave him. I have my N, my D, and then my Q equal my number. That one's fine. My second equation has to be reordered. So I need to bring this 2D to the other side. And when I do, I still don't have any nickels. But when I bring him over, the 2D becomes a negative 2D. And then I have my plus Q. And that leaves me nothing else on that side. And then I have my last line. And that is also in a correct order. So once I have all my N's, all my D's, all my Q's lined up, all my numbers, I can then make my matrix. So I again take my values, 0.05, 0.1, 0.25, 0, -2, 1, 1, 1, 1. I'm going to take the inverse of that, and then I do my last matrix as well, 660, 0, and 42. Once I have all of that listed, now it just takes time to put it in my calculator. So second matrix, over to edit. Again, this is a 3 by 3. I just have to change my values in it. I then go second matrix again, over to edit, down to B. He is a 3 by 1. Once I have that entered, I quit. And I go matrix A, inverse, matrix B. And you will see my values are 12, 10, and 20. So what this means is that there are, because my ends were first, means there were 12 nickels, there were 10 dimes, and there were 20 quarters. All right, let's try one more example. If you flip your page. So on our last example, we are going to talk about how to do this one more time with matrices. It says a theater has tickets that are $6 for adults, $3.50 for students, and $2.50 for children. Okay, that total equals this $1,300. I also have another total of 278 tickets, and those are adult and student and children. The last line says the number of adult tickets sold was 10 less than twice the number of student tickets. So the number of adult tickets sold was 10 less than twice the number of students. So if I take and multiply my students by 2 and subtract 10, that will give me my adults. So my first line is set up perfectly. My second line is set up nicely. But my third line, my A is good. When I bring my 2S over, it becomes a negative 2S. There is no C. And then on this side, what's left is a negative 10. Once I have that set up, I put it in my matrix, just like we've done in the past. I'm going to take the inverse of that matrix and multiply it by that one. And then I'm going to get out my calculator and punch in the information. So again, go to Matrix, over to Edit. This again is a 3 by 3. So I go 6, 3.5, 2.5, and make sure you're hitting Enter in between each one again. I again go second Matrix, over to Edit, and I go down to B this time. B is again a 3 by 1. And once I'm out, I then go second matrix A inverse, second matrix B, and I get my answers. 150, 80, 48. So my first line was my ACE, so that means there are 150 adults, 80 student, and 48 children tickets.